the 6 formulas. So I will write this one as 1 divided by, so 9x whole square, I can write this one as 3x whole square, plus I can write 6 as x 2 into 3x. Now from by writing like this, you can see that I'm trying to express it as a square plus 2ab plus b square. So I got my a square, I got my 2a, and b will be 1 because it's 6x, so 2 into 3x into 1, that is, and plus b square is 1 square, that is 1 only, minus 1 because we have added plus 1 in here, so that's why minus 1, and plus 5 dx. So this is what we have. So this becomes equal to integration of, now if you look at carefully, this entire thing is nothing but a square plus 2ab plus b square. So in place of that thing, what I'm going to write is 3x plus 1 whole square, and minus 1 plus 5, that becomes 4, and that basically is equal to 2 square. So we get kind of like a form of this one. So this one we are getting in this form. So integration of dx, x square plus a square, this form. So but here the problem is that there is 3x plus 1. So how can I remove that 3x plus 1? So we will be using method of substitutions. So in here I will write let 3x plus 1 is equal to t. So if I take 3x plus 1 is equal to t, therefore differentiating with respect to x, we get 3 is equal to dt dx. So therefore dx is equal to dt by 3. This is what we have. Now let us write I. So what does my I becomes after substitution? So the substitutions which we are going to use is this one and this one. So let's see what happens. So I is equal to 1 divided by, in place of 3x plus 1 I will write t square plus 2 square, and in place of dx I have dt by 3. So I can take 3 out, so I get 1 by 3 integration of dt divided by t square plus 1, t square plus 2 square. Now if you look at this one, this formula is quite similar to this one. Now what was the formula of this one? The formula of this one was 1 by a tan inverse x by a plus c. That was the formula. So in place of x I will write t, and in place of a I will write 2. So I have 1 by 3 into, so 1 by a, so I have 1 by 2 tan inverse x by a. In place of x I will write t, and in place of a I will write 2 plus c. Now t will become what? So it becomes 1 by 6 tan inverse, in place of t I will write 3x plus 1, 3x plus 1 by 2 plus c. That's how we solve question number 11. Now let's move on to question number 12. So question number 12, the question it says is 12 I is equal to integration of 1 divided by, now the square root we have here, so we have 7 minus 6x minus x square dx. So this is what the problem is. Now in here we see that the x squared term is in negatives. So what we are going to do is, I am going to leave 7 aside and take minus common from here. Now if I take minus common, so what we have, x square plus 6x, we have this thing. Now I will try to write this inside portion, inside the bracket portion, as a square. The method of squaring, we'll try to do that thing. In quadratic equations in class 10 we have done method of squaring, right? The same thing we are doing in here. So we have 7 in here, minus I will have a square, that is x square, then plus 2 into x, that is 2 into a, and the b will be what, 3. How come we know it's 3? Because 2 into 3 gives us 6x, right? Then plus what we have, plus b square is what, 3 square, and we also have minus 3 square, because b square we have not got from us It didn't fail from sky, it was created by us. So we have to cut 3 square, and by how can we cut? By having minus 3 square in there. So this is what we have. Now after this, let us take this minus 3 square outside. Why we want to take? Because this entire thing in this bracket we have in the square form, which we wanted to do. So we have dx divided by, now if I take minus 9 outside, so minus minus becomes plus, so it becomes plus 9. So I have 7 plus 9 is 16. 16 minus, and this portion becomes x plus 3 whole square. It becomes x plus 3 whole square. So this is what we have. Now it looks similar to that. Achha, there is a square root. I am very sorry. We cannot miss out like this. There is a square root. So this looks similar to integration of dx root over of a square minus x square. This is what it looks similar to. And if you just roll back to your formulas, this formula, what was the formula of? It is the sine inverse x formula. It is sine inverse x by a. So I will write here sine inverse x by a plus c. So what do I have in here? The value of a is what? A square is 16. So the value of a is 4. And the value of x is what? X plus 3. I will not use substitution in here because there is nothing multiplied with x. Since there is nothing multiplied with x, no need of having substitution. Just in place of x, put x plus 3. So the answer will be sine inverse x plus 3 divided by 4 plus c. So use substitutions when you have something multiplied with x. Okay, but here nothing is multiplied, so there is no need of using substitutions. So now question number 12 is done. As a question number 13 will be same as 12. All you have to do is do the multiplication first, then you have to do the same thing. You have to find the square. Question number 14 will be homework, same. Let's do question number 15. Question number 15. So question number 15, what we have is integration of 1 divided by root over of x minus a whole and x minus b. These type of questions is all about practicing. If you practice, all you have to get is try to have it in the form of the 6 formulas which we have. So we have to integrate this one. The first thing what I will do is I will just do the multiplication. So what do we have? 1 divided by root over of, if I multiply we get x square, then we have minus bx, then we have minus ax, and then we have plus ab. So this is what we get, dx, and is equal to, we can write this one, let us write nicely, then it will be easier to solve. So we have x square minus a plus bx plus ab. So this is what we have. Now here again the same thing, we have to express it in the form of a plus b whole square. So let us have this one, integration of 1 divided by root over of, we have x square minus 2ab, right? So 2 into, I will write here x into, and my b will be what? It will be a plus b by 2. It will be a plus b by 2, because 2 gets cancelled and it becomes what? A plus b into x, right? And we have b square is what? A plus b by 2 whole square. This is my b square, and for this one I need to have minus a plus b, minus a plus b by 2 whole square, and the last one which we have is ab. So this is what we have. So after this, what we are going to do is we're going to write integration of 1 divided by, now this entire thing if you look at, it becomes what? X minus a plus b by 2 whole square, x minus a plus b by 2 whole square, and this one, let's do this one in the rough. So let's do it in here only. So this one, if I take LCM, it is actually a plus b whole square by 4 plus ab dx. This is what we have. So what we are going to do is, I will just do one thing, I will just copy this thing, copy, and I'm going to paste it here. paste. So this what we are discussing, we are finding this one, right? So now after this what we are going to do is we will simplify this a plus b whole square by 4 plus ab. So what do you get? Integration 1 divided by x minus a plus b by 2 whole square, and if I take minus common, this becomes 4 a plus b whole square minus 4ab dx. Now if you look at it carefully, a plus b whole square is what? A square plus 2ab plus b square minus 4ab. So it becomes what? A square minus 2ab plus b square. So this is nothing but a minus b whole square. So what do we have is x minus a plus b by 2 whole square minus a minus b whole square by 4. Look, if you have doubt, just look at here. A plus b whole square is what? This is a plus b whole square. Now minus 4ab, that gives us what? A square minus 2ab plus b square, and that becomes what? A minus b whole square. This is what we have, right? Now after getting this thing, we can look at here. This one is written as what? X square minus a square. Okay, one thing, there was a square root, right? Please don't forget putting the square root, because if you forget putting the square root, so the whole formula will be different. The entire formula will come out to be different. So please remember the square root is there. So this one looks similar to this. So we will be using root over of x square minus a square formula. And what was that formula? It was, the formula of this one was what? Log of x plus root over of x square minus a square plus c. This formula. So I will be applying it here. So we get log, in place of x I will have x minus a plus b by 2, x minus a plus b by 2, then plus root over of x square minus a square. Now one thing you see, this x square minus a square is this thing, right? And this one, this inside thing I got from where? I got from this only, right? After simplifying this thing, we got this entire thing, right? Yes or no? So I will just write the simplified form. I don't have to write this entire thing. I will write the simplified form, that is x square minus a plus b x plus ab. Or else you could have written this one also, no problem. Or else you could have written this one also, no problem. So this is what my answer for question number 15. Yeah, so question number 15 is done. So now the different type of problems comes, that is question number 16. Now question number 16 will tell you a different category of problem. Now what is that category? Now before starting with question number 16, I need to discuss something. Now you see here, this problem, question number 16, it looks like integration of I is equal to integration of 4x plus 1 divided by root over of 2x squared plus x minus 3. This is what we have, right? This problem. Now this problem is quite easy. So I told you that if you look at the 6 formulas, there is nothing, none of them has something in the numerator. But in this question, it has something in the numerator, that is what? 4x plus 1. So for this problem, what I will do is, I will write the denominator, whatever is inside the square root, in the rough, and I will try to differentiate that thing. So 2x square plus x minus 3. If I differentiate that thing, we get 4x plus 1, right? And once you get 4x plus 1, we can see that we can just use method of substitution to solve this problem. So this problem is quite easy. So I will write here, let 2x square plus x minus 3 is equal to t. So differentiating with respect to x, we get 4x plus 1, and this becomes what? dt dx. Sorry, we have square root in here, so I will take t square. I'm telling you to take t square because once you take t square, the square root will no more create a problem. So we get 2t dt. This is what we have. So in place of 4x, so we have to write what? dt dx. So therefore dx is what? Therefore dx is equal to 2t dt divided by 4x plus 1. In place of dx, I will write this, and in place of 2x square plus x minus 3, I will write t square. So what does my I become? Therefore I is equal to what? Integration of 4x plus 1. I will not do anything with that now. The denominator becomes what? Root over of 2x square plus x minus 3 is what? T. And dx will become what? 2t divided by 4x plus 1 dt. So t gets cancelled. 4x plus 1 can cancel. So we have integration of 2 dt, and that is nothing but 2t plus c. And that is nothing but 2 root over of t is what? 2x square plus x minus 3 plus c. So once you have something in the numerator, always try to differentiate, always try to check differentiating the denominator and see whether you are getting the same thing as the numerator or not. So once you see that, so you don't have to worry about the formulas. It's just method of substitutions you have to apply and solve the question. Now let's see question number 17. Question number 17, I will not do the entire problem. I will just give you the hint of question number 17 and you can do the problem. So question number 17, it says it is I is equal to what? Integration of x plus 2 divided by root over of x square minus 1. So once you look at here, what I told you, what? I see something in the numerator, x plus 2. So I will try to differentiate the denominator, x square minus 1. If I differentiate, I get only 2x, only one term I get. So once I see I get only one term, but in the numerator there are two terms. So what I will do, I will separate them. So I get x square minus 1 dx plus integration of 2 divided by root over of x square minus 1 dx. And by separating them, I am just making I into two different integrations. This one is I1 and this one is I2. This I1 you can easily do by using method of substitutions. You will just write x square minus 1 is equal to t square. So you will just substitute. You just write this one at home. So you will write substitute x square minus 1 is equal to t square, and you can easily solve this one I1. And what is the solution for I2? I2 is what? The 2 will come out. So integration of 1 divided by root over of x square minus 1 dx. And the formula of this one we already know. That is what? It is 2 log x plus root over of x square minus 1 plus c. C2 you write. So you solve this one, then you add them together and you get the value of I. So that's how you do question number 17. Okay. Now we have question number 18. So question number 18 is a very interesting question. So now actually the problem starts. Generally if a problem comes from this exercise, it will generally come from question number 18 onwards. But it doesn't mean that you will not practice questions from before 18. So we have this integration, I is equal to 5x minus 2 divided by 1 plus 2x plus 3x squared. So again you see there is something in the numerator. It is 5x minus 2, right? So once you see something in the numerator, what I will do is I will try to differentiate the denominator. And what is the differentiation of the denominator? So 1 plus 2x plus 3x squared, if I differentiate, I get what is 6x plus 2. I get this thing. But here the denominator is something different. It is what? It is 5x minus 2. So what we are going to do in here? So here what we are going to do is, this thing you have to remember. So I will try to manipulate the numerator into finding something of 6x plus 2. So how we are going to manipulate? So I'm going to write here 5x minus 2. From 5x minus 2, I will try to get a differentiation of 1 plus 2x plus 3x square plus b. So basically what I am doing is I am changing the numerator 5x minus 2 into something like this, which has the direct derivative of the denominator and a constant. Okay, so I'm basically changing the numerator into something which will be further easier for us to integrate. So how do we do it? So I will write 5x minus 2, then a, we already see the differentiation is what, 6x plus 2, 6x plus 2 plus b. So what are the values of a and b that we have to find, so that we can easily write the numerator in terms of 6x plus 2, because once we get 6x plus 2, we can easily use method of substitution and we can integrate, right? So all we have to do is find the value of a and b. And how can we find the value of a and b? You see here, if we equate the coefficient of x, now equating the coefficient of x both sides, what do you get? Equating the coefficient of x, so from the left hand side the coefficient of x is what? 5. But if you look at the right hand side, the coefficient of x is what? It is 6a. A is multiplied 6a. So therefore a is becoming 5 by 6. This is the value of a. Now what is the value of b? How can I find b? B can be found out by equating the constants. Equating the constants, we can find the value of b. So what is the value of constant in the left hand side? It is minus 2. And what is the value of the constant in the right hand side? It is 2a plus b. Now we already found the value of a, and let us put the value of a in here. So we get what? Minus 2 is equal to 2 into 5 by 6 plus b. So we get 3 in here. So therefore b becomes what? Minus 2 minus 5 by 3. So how much is it coming? Minus 6. So it's coming minus 11 by 3. It's coming minus 11 by 3. So my a is becoming 5 by 6 and my b is coming minus 11 by 3. So what was the purpose of doing this thing? Now in place of 5x minus 2, now you see what I am going to write. Now in place of 5x minus 2, I am going to write I is equal to integration of, now 5x minus 2, what I have written? A into d dx of the denominator plus b, right? This was, so in place of 5x minus 2, I will write a. A is what? 5 by 6. 5 by 6, 6x plus 2. Then plus, b is what? 11 by 3, I guess. Minus 11 by 3. B is minus 11 by 3. So I will write minus 11 by 3. So basically, what I have done is, I have changed the numerator. So we have this thing. So this is what we have. Okay. Now once we get this thing, so what I will do is, now I will separate them, because if you differentiate the denominator, now you can easily integrate the first portion. So what we have, I is equal to integration of this 5 by 6 is constant. So let us take 5 by 6 out. We have 6x plus 2 divided by 1 plus 2x plus 3x square. Now this integration is quite easy. Why? Because if you take the denominator as t, you will get the numerator. And the next one is minus 11 by 3 is outside. We have 1 divided by 1 plus 2x plus 3x square. Now there is more things to be done in the second part. So I write 5 by 6 I1 minus 11 by 3 I2. The first part I1, how will I do I1? So I1 is this one, and it's quite easy when you look at I1. So I1 I will do what? Let 1 plus 2x plus 3x square is equal to t. So differentiating with respect to x. So you get 6x plus 2 is equal to dt dx. So therefore dx is equal to dt divided by 6x plus 2. This is what we have. Let's substitute. So therefore I1 is equal to integration of 6x plus 2, let's not do anything with that, divided by t into, in place of dx I will write dt divided by 6x plus 2. So this 6x plus 2, 6x plus 2 get cancelled, and what we have is log mod t plus c1. And what is t? t is nothing but log 1 plus 2x plus 3x square plus c1. So we have already got the value of I1. Now let's try to find I2. What will be our I2? Now I2 is given by 1 divided by 1 plus 2x plus 3x square. But for I2 we need to work some further. Why? Now look at here. In case of I2 we need to express it in the form of square of something, right? So how can I write this one? I am going to write this 3x square as root 3x whole square. Then this 2x I can write 2 into root 3x, because a square plus 2 into a, this is root 3x is a, into b will be what? B will be such that we get 2x. So b is what? 1 by root 3, because root 3 gets cancelled and you get 2x. And then you have plus 1 by root 3 whole square, then minus 1 by root 3 whole square. So basically it's 1 by 3 only, but still we're going to write this thing, minus 1 by root 3 whole square. And what is the last thing which we have is plus 1, and let's write dx in here. So we get dx, this entire thing, this thing is nothing but root 3x plus 1 by root 3 whole square. This one is what? 1 by 3 plus 1. So basically it's coming out to be plus 2 by 3 is equal to integration of dx divided by root 3x plus 1 by root 3 whole square minus plus 2 by 3. This is what we have. So let us do some substitutions. So here I will do substitution. Let root 3x plus 1 by root 3 is equal to t. So differentiating with respect to x, we get root 3 is equal to dt dx. Therefore dx is equal to dt by root 3. So let us put that thing in there. So here my I2 will become what? Therefore I2 is equal to integration of, so in place of dx I will write dt divided by root 3. In place of root 3x plus 1 by root 3 whole square, I will write t square, and in place of 2 by 3, nothing to be done, I will write 2 by 3. Okay, so this is what we have. So this looks similar to dx divided by x square plus a square. So basically the formula of this one is what? 1 by a tan inverse x by a, that was the formula. So 1 by root 3 taken out, it will be 1 by a, right? So the a value is what? Look, a square is equal to 2 by 3. So the value of a is what? Root 2 by root 3. This is a. So 1 by a is what? Root 3 will go up into root 3 by root 2 tan inverse t divided by root 2 by root 3. Okay, clear? It is t divided by root 2 by root 3. So root 3 gets cancelled. We have 1 by root 2, and this becomes what? It becomes tan inverse t. The value of t is what? Root 3x plus 1 by root 3. Root 3x plus 1 by root 3. And the value of this one is what? Root 2 by root 3. Now if I do the LCM, what do I get? 1 by root 2 tan inverse, numerator becomes 3x plus 1 and denominator becomes root 2. So this is the value of I2. The value of I2 is this one, the value of I1 is that one. So therefore I is equal to what? I know it's getting lengthy, but these questions are very, sorry, we have to find I. Therefore I is equal to what? I is equal to 5 by 6 I1 minus 11 by 3 I2. So we get 5 by 6 log of, what do I get? 1 plus 2x plus 3x square. 1 plus 2x plus 3x square minus 11, 1 by root 2 is there. So minus 11 by 3 root 2 tan inverse 3x plus 1 by root 2 plus c. Achha, this one is, there will be a constant in here. We have to write c2. So that's my answer. So this is how I get